Hello and welcome to a recording of a talk I recently did at CodeCamp Wellington. CodeCamp is held yearly here in Wellington, New Zealand, and it's an all-purpose tech conference that's free to attend. You can check out codecampwellington.nz for more info, and thank you to the CodeCamp team for having me along this year. My talk was called Gaming PowerShell for Fun and Profit, and it was a way to introduce people to terminal programming by way of building a simple game. Now I can stop reading my notes and start winging it. Okay, so my talk was mostly about terminals and terminal programming. I start with an intro. So this down here, which you can see in the bottom of the VS Code, is what you'd call a terminal. And this is where you type commands and things happen. So npm is a very common one people need to use all the time. So you can imagine node install or whatnot. Or when people are asked to run executables, the /setup.exe, this is where all of the magic happens. If we type something like this function in PowerShell, get child item, you can see that we've got some nice colors happening. Now, how do colors and things work? And how do things like this clear host, how has that gone and wiped everything off the screen for me? I can't scroll back up anymore. These are all done by things called escape codes, and we need to know a little bit about them to get more comfortable with how the terminal operates. So I've written a small script here to get started with them. My escape code's PS1, and we're going to learn a little bit about how these things happen. We can type something simple in here, like hello world, and it's just going to show me the text hello world and the terminal output for hello world. But if we start to use some of these weird escape characters, like backtick A, we'll be able to see a different output. So that there makes an alert sound. It also collapses it from the output, so we don't see it anymore. So this is like generating a side effect in the terminal. It's not really something that the user sees. And there are lots and lots of these. Some of the more fancy ones do things like formatting the colors, which you would have seen in that terminal output of get child item. So now we can do something like change that text red. And this is an RGB value, so it's got some weird numbers at the start, of which I have no idea why they're those numbers. And then we've also got these 255, 0, and 0. So those there are going to be the bytes for the color. So if we flip this around a little bit, switch it to 0, 2550, we should get RG and B, so that should be green now. So these codes are a little bit hard to read, and yeah, you wouldn't be expected to remember any of these. It's just good to know that this is how the terminal is being driven behind the scenes. So when you do something like set the foreground color or the background color, when you're using something like echo or write host for PowerShell, this is how it's actually telling the terminal what to do. Depending on the terminal, the codes are slightly different too. For the purposes of this, we just need to know that escape codes are happening. This last one here is the part that I need to understand to be able to do kind of animations in the terminal. So if you think about something like Docker or npm install, whenever you run these things, they show like loading bars. And they're able to update things on the terminal without scrolling all over the place or clearing your output. And they do this by moving the cursor around. So the cursor being this little bit here that's flickering now over the character W, there are special commands to send that to places on the screen. There's commands to send it to the back of the end of the line, start of the line, top of the terminal, wherever you want it to go. Some of these are very handy, especially things like this, backtick E square bracket 1b. Sound like a robot. Backtick E square bracket 1b. Hello world. We can run here now, hello, this 1b1 world. So what's happened is that's actually sent that character, that cursor down one line and then continued writing. And if you think about how we can do things like a loading bar, we can write hello, then we could send it back 5 characters and then write world. So if we do something like that, we'll try, what ones go left was the D, so we'll change this to E5D. Now if we write hello world, what we should really just see is world come out. So we wrote hello and then wrote world over top of it. This is how you would do something like a loading bar. Obviously something would happen between those two writes. So you would write, send it back to the start of the line, do some stuff, and then write it again. So it would kind of have the illusion of being animated. And then the last one I've got on this list here is backtick R, which just goes back to the start of the line, because sometimes it's very useful to know that you can do that. hello backtick R world. So that's going to take me back to the start. And apparently I wrote world there. Okay, so that's a little bit of an intro on escape codes. And now we will start a little bit on what the game is. So we're going to do this in the context of writing a game, and I thought I'd give a demo of what the game is actually looking like. It's called Snake. It's something I was always playing on my phone when I was at high school. I've done a little example here of what my phone used to look like. This is a good old Nokia, the peak of phone engineering. And this is what the game would look like. So we've got a basic output here of a thing on a screen, which we drive around with some arrow keys, and we collect the food objects. And then eventually we crash into ourselves and die. So it's a very simple game. There's only one animated entity on the screen, which makes it a little easier to program than a lot of things. It's why I like to use it as an example when I'm just learning new languages, when I'm just playing around. Okay. Now, an intro to PowerShell itself. We've talked a little bit about the terminal. PowerShell is just one language of many that we can be using down here. I use a PowerShell. So the terminal is the box that you're typing in, and the interpreter is what's currently running and executing the things that you're typing. So for me, I'm running PowerShell. So I can do things like get child item, which is going to give me what's currently in the directory I'm in. Get the children of the thing I'm in. This special character dot means the current directory, or dot dot means the parent. Now, there are different terminals. If we switch into something like WSL, this one here is bash. So we don't have get child item anymore. Command not found. We have something like ls or lsal, if we want to remember. It looks something like the child item output. All of these terminals are different. You've got fish shell and Z shell on Mac OS, and all of the ways these things work are very similar. So I was doing my example before in PowerShell, and if I remember rightly, it's something like echo e /e. What was my example code? Actually, we should be able to run it in here. PowerShell, and then if we run that script, we hope. So you can see I'm in Linux now, and I'm running my PowerShell script. It's using these same characters. They still get interpreted very similarly. So if I type hello again, world, we should still get red world. So the things you're learning are not just PowerShell specific. The way the terminal works is kind of agnostic. This is the host that the terminal applications run in. Now, I'm going back to Windows land instead of my Linux one, so we can start talking about the script. So there's a few things to talk about here. This first line, if you're going to be writing PowerShell scripts for anything other than Windows, you're going to need to remember that this should be there. It tells Linux or other shells, bash, whatever, how to run your PowerShell script. On Windows, it sees the PS1 extension and it knows how to run this. So if I just run them like that, one intro to scripts, we're going to get the output. If we were still in Linux here and I tried to do that, it doesn't know how to do it because I've got it in a Windows line ending. I've been talking a little bit about that backtick R that goes back to the start of the line. That's how Windows does new lines. So Windows has carriage return line feed, which is carriage return back to the start of the line, and then line feed like an old typewriter, so it does two operations, which right now is breaking this because Linux doesn't care about those /Rs. It just wants to see a line feed. I can change the format of this file to fix it. And hope. I didn't hit save. Let's try that once more. So now it's read the first line and it knows that it's trying to use PowerShell to execute it, so we've executed it. So that's hello from PowerShell under Linux. If we don't have this line, it's not going to know what to do, and it's going to break. Yep, doesn't know what to do about it. It's treating it like it's a normal shell script. So that line there is just a shebang, that's what it's called, I think. It's a common character set, just most shell scripting languages use a hash character for the comment lines, so that this line will get dropped by anything like PowerShell. It doesn't care about it. it thinks it's a comment, it just carries on and executes the rest of this. But when Bash or the PowerShell terminal or whatever have actually interpreted this file, it reads the first couple of bytes to work out where to go next. And if it sees that hash and then a bang, it knows that it's going to need to figure out where this fella lives. Okay. Now that's the shebang line. We've got two other things to talk about here. We've got a parameter block. So this here is actually telling us what parameters the script takes. You can see I've been running it and it hasn't been telling me off because it's not a mandatory parameter. It's just empty, coming up as an empty string. So down here, things is not evaluating to anything. But if we put it in here, hello Sean, we should get some output. PowerShell is pretty loose like that. It's going to just let you collapse variables into their default state. So if we had another parameter, which was something like a number, I'll just call it width for now. And we put it in our output text. Hello Sean 0. So we didn't provide width, but it has gone and assumed something about it. So let's put in 1, 2, 3. Now this is called positional script parameters. So I'm just saying Sean is the first positional one and 1, 2, 3 is the second. What would happen if I wanted to do these backwards, or if someone refactored the script? It would break. Shayon. So at the moment it's trying to convert Shayon to a number on the second line and it's getting upset about it. The way we pass these parameters in PowerShell is to use named parameters, which start with a hyphen like this. And if you hit something like control space, you'll invoke autocomplete and you can see what's available. We wanted to provide width here, and we wanted to provide things as the other one. Oopsies. You can also type tab to complete these. So hello Shayon 1, 2, 3. It's best practice to just always use named parameters when you're calling scripts or functions, just because otherwise it can break in weird and wonderful ways down the line. So we have started a few things there, and now we've got to this line called write host. So we've talked a little bit about how the terminal is text-based. Its input is text and its output is text primarily. So write host is going to write some output to the host. The host is the terminal. In this case, it's the VS Code terminal. It could be the Windows terminal or command prompt or whatever. And so now we are telling it to write to it. So it's also magically done string interpolation here. So these variables, we've just referenced them in the string and it's gone and stuck them right in there. So effectively what's happening behind the scenes is it's calling toString on those to get a string version of it for the output. So that's your basics for a PowerShell script. And yeah, the suffix of PS1, and I have no idea what the 1 means, but it's just there. And I've talked a little bit about these data types. Bash scripts are primarily text-based, so having numbers here is a bit interesting. And we can do something like return width at the end of this. So we've run a script here, we can assign it to a value. Variables have a dollar value if you haven't clicked already. This one, so we'll call this output var, and we run the script. Now what is output var? It's 1, 2, 3. But with other scripting languages, you may be getting text back, and in this case, we're actually getting an object. So output var.getType is going to tell us what it is, and it's a system value type of int32. So this is actually the same data types you'd be familiar with if you've done any .NET. PowerShell is just .NET behind the scenes, so all of these things like output var have all of the same functions available that you'd expect on those objects. So this is where it starts to get cool, and it's why I've kind of switched over from doing a lot of shell scripting in other languages. I wrote Bash stuff when I was like 13, and since then I've kind of just gone off it because I found this much more enjoyable. All right, especially since this is actually cross-platform now. It used to not be. I would never have actually got into it if they hadn't supported Linux and Mac OS. All right, so this PS1, we've done a little bit about data types here, and yeah, there's one really powerful one for PowerShell, which I haven't really covered, and we're going to need a lot of, which is the has table, the hash table. Now the hash table looks like this. It starts with a @ symbol and a curly bracket. And if you're familiar with anything like Python, it's a dictionary. So when we define this thing hash table, we should be able to access the variables. Let's just return it out of this function, out of the script. Yep. And run the script again. And what's our output bar? So you can see we've got a different type of object here. It's got a name value set, and it's got two names, width, which is 1, 2, 3, and things, which is Cheyenne. So if we go output var, we can access these just like a normal dictionary. Whoops, things. Tab complete works on those properties too, which is nice. So output var things is Cheyenne, and output var width will be 1, 2, 3. You'll find it's common also to refer to these with dot notation, so we can call dot width or dot, what was it, things, which does the same thing. These there are super powerful because they're super flexible. They can also bite you in the butt when you forget how you define the object shape. So they're not as strict as things like classes, which you can do in PowerShell, but we're not going to talk about today. Okay, so we've got the basics of the script, a little bit about simple data types. There are other ones which we'll get into as we fall into them, so arrays, lists, and other simple value types. But for now, we can start to think about how we'd represent a game in this thing. So it's a relatively limiting interface, which is good because it only gives us one real option, which is to draw the game using characters on the keyboard. So if we were to look at the terminal and we think about what we want to do, we want to draw a grid. So we want to go down a certain number of lines and across a certain number of lines or columns. This here is our rows, and this here is our, this on the right left is our rows, and down on the bottom is our columns. Because we're going to be doing line by line, we're going to start by iterating through each of these rows, and then we're going to, on each of those rows, type each of the column letters. So we'll just write something up here. We'll reuse this script. We're going to want to provide two parameters because we want the width and we also want the height. My typing is atrocious on this keyboard. And we're going to do it with a nested for loop. So for each row, we hope it does it for us. For each row, we're going to increment it while it's less than the height that we want. And then for each column, we're also going to increment it while it's less than the width. This here, right host, has written to the host a asterisk character. I'm going to switch that up and just put a big X. And it's also provided this flag called no new line. Now we've got a function here which we've been calling called right host. You'll notice PowerShell doesn't use parameters for function calls like this. It uses this hyphen-y thing, so hyphen no new line. You might be thinking no new line is being provided the value X, but that is not the case. So no new line is what we call a switch. So if you used other tools like you may have called help before. So npm help. So help doesn't take a value saying something like true. Help is just help. So that's what a switch is. It's similar up here. No new line is just saying no new line. What's actually happening is this is a positional parameter, which I should probably use the name for, but because it's so common, I don't, which is message. So message X is actually being given the value. We're going through writing right host no new line, so we don't want a new line after each X, or else we're going to write a big stream of X's the whole way down the terminal. And then every time we get to the end of a row, we're just going to right host just nothing. We can put EOL here just to show where the end of the line is, but we'll get rid of it afterwards. So let's run this once more. Oh my gosh, I've got so much stuff there. 1. Yep, and I didn't provide any values. I don't want to have to provide the values every time, so I'm going to set some defaults here. Yeah, and we can see how we wrote this. So we've got all our X's here, and then on each end of line, we've done EOL. Now that we see where the end of the line is, I'm not going to actually write that out. But we can see we've got a problem. So each of these characters is actually twice as wide as it is tall. So X takes up a certain amount of space in the terminal. We're going to need 2 X's to be able to actually draw something that's wide enough to be kind of a square. So let's just do 2 of these for now and try to get this thing squared up. So we're looking good. So this is what we can consider our pixel. It looks pretty garbage though. So what I'm going to do, we could use escape codes for this, but I'm going to use one of the convenient parts of PowerShell and just set the background color this way. We're going to choose dark blue. That's actually kind of a string, but it looks that way. So dark blue, message XX. And now because we have a background color, we can actually get rid of this. It's just going to look kind of like we're drawing a picture. Looking tight. All right, so we have something here which looks cool. Objectively, it's like definitely sick. And now we need to start doing something to make it look a little bit more like a game. So we've written the game board or frame. We need to come up with a way to represent the food and the snake. So I mentioned the data types. Snake here, Shibinek, is going to be a collection of, like, I guess, pixels. So we have the snake. It's going to take up a certain amount of space to start with, and then as we grow longer, it's going to take up 2 spaces, 3 spaces, 4 spaces. And we're going to need to remember the position of each of the pieces of the snake. So we're going to use this, which is the array initializer syntax thingy for PowerShell, which looks a lot like a hash table. The hash table is the curly brackets, but this one is parentheses. Now, we don't want to start with an empty snake, a 0 snake. We want to give it some position. So we're going to use one of those hash tables to represent the coordinates. Now we can use x equals something. Let's go x equals 5, y equals 5. So just to start with, it should be roughly near the middle of the map. And now we have a snake. How are we going to try and draw it? So we're already iterating through every row and every column. We can basically check every time we're on a column if we're on the same position as the snake. So we're going to start just using the snake, just use one of those items from the array, which we can access with square brackets like this, similar to most array access in almost all languages. And we want to check if the x is equal to the column and if the y is equal to the row. If it is, we're going to write it in a different color. We're going to use dark green because it suggested it and it looks good. Otherwise, we're going to continue and just draw the background the same way we did it before. So now we're checking for the snake. Oops, check for collisions. And hopefully we get a green block in the middle-ish of our thing. So that's cool. And now one of the things I always like to check when I'm doing anything to do with rendering or drawing is to make sure I got my coordinates right. So I'm going to change this to 1 and make sure that it goes left. Yeah. And then change this to 1 and make sure that it goes up because I want them to be like that. It's very common if you're doing anything like writing graphic stuff to get them flipped or forget about which way you had them around. So it's always good to check that stuff. Okay, so we now have our snake. We're going to do the exact same thing for food, but food is a single item, so we don't need to define a x and y in an array. We can just do a simple one, x equals 3, y equals 3, that'll do. And we haven't added a collision, so now we're going to add that. A bit tired. This will be else if some people hate the way I format my PowerShell, but oh well, I wait for the formatter to do the hard work later. So food.x and food.y. We don't want dark red, dark green. We'll choose something like dark red so we can kind of see the different colors. And I messed up how I did my else if. Cool, so now we have 2 objects in the game. At this point, if we continue down the path of continuing to keep writing spaghetti into this one PS1 file, we're going to get pretty overwhelmed with a very long script, which often used to happen to me when I was writing bash scripts. Doing modules here is actually really easy, so I'm going to teach you how to pull some of the stuff out into a separate file. To start with, we're going to need to take some of this logic and wrap it in a function, so we'll just do it in here to begin with. We'll use the function keyword to define a new function, and then we will come up with something we want to generate. So we'll do the food. When we create some food, we want it to be kind of random. So we'll do get random food, or yeah, food works. And then we're going to define our function. The function looks exactly like the script, so we want to provide some parameters to this. We use the same param block that we used at the top of our script, and we're going to provide width and height because I want to generate some food within the dimensions of our game. I'm going to let this autopilot me through it, speed things up. So our food is going to be built up of a hash map of x and y, and we're going to get a random value between 0 and the width of the game. Get random is a built-in function. If I hover over it, it's going to give me the instructions about it. And then we can just return this value. Now, we can just swap this one out. So we want to call get random food now. And hopefully our game still works. It's always good to keep checking these things as you go, especially when you're letting Copilot do half the driving. So now we've got a function here. We're going to need to pull it out into a separate file. Importing a module is relatively easy. We just call import module, and then we give it the name to the module. We'll call this one snake module.psm1. And while you're developing, always chuck force on the end so that it pulls the latest version, and otherwise it will pull a cached copy and you'll be stuck wondering why your changes are not taking effect. What do we call this? Snake module.ps1. Oops, I just started writing it there instead of the name. So this is going to be our snake module. You notice that the file type extension for a module is PSM1, not PS1, because this isn't a script, this is a module file, but they almost are identical. There's no boilerplate in here, we just chuck a function in, and there are ways to do this a lot more properly, but for now it just helps to kind of hide things around. So we're importing this module here, snake module, and we're writing with get random food. There's probably a couple of other things we want to do here. One of which is I kind of want to just collapse this a little bit. Whoa, did not do what I wanted. Join lines. And then we're going to need to pull some more stuff out into a function. So this here is really our rendering function. So I'm going to grab this and come up with a new function name. I'll do it in here. Function right game board, that'll do. Then we're going to just paste it in. All right, that kind of worked. So we want to do here now right game board. One thing yeah, that's right. Right game board. Game grid is from another module. That's from my Nokia that I showed before. Right game board width, height, snake, and food. So those are probably the things we need to provide to it because our game board needs to know about all of them to draw it. And we're going to hope that Copilot can fill them out because we cannot be bothered typing width, height, snake, and food. One of the things you may notice here, if you've got sharp eyes, is that these here are not case sensitive, the variable names. So you'll never get an error for that. I like to be a little bit pedantic when I'm chucking them through. So capital Fs, usually these have a capital name, and then variables defined within the block scope usually don't. Okay, well, let's check if this is going to work. Save both of those, run it once more, and we've still got a little game screen. So far so good. We've pulled out all of the logic and hidden it away in this module file. You could break things up into logical modules depending on how you want to pull things apart. And for now, we're just going to use one ginormous one and just keep dumping functions in there. We've got our new random food position. We're just always starting the snake in the middle. And then our game board here is going to be rendering it. So we've covered off these two. Now, we've also covered off how to write a little bit of a modular shell script, how to move our logic out of the main script. And this piece here I have not touched on. So at the moment, I'm doing a lot of the same bits and pieces over and over here and testing if the pixel collides with the object is going to be required in more places than this. So we're going to write a function to do the collision check. So let's call it something like test collision. And yeah, it's just taken what I had up there and put it into a function. So test collision, it's not always going to be a snake that we're passing in. It's just going to be a thing, and it's not always going to be food that we're checking against. So position, we're going to be providing the position as a hash table. No, we're not. I'm going to do position X and position Y because I think that's an easier way of doing things. And we're also going to provide the object to test. Because of the .NET and everything kind of inherits from the object class, we can just say that this is an object because we don't know what we're going to be passing right now. And it's not always a snake, so we'll just update this. And it's position X and position Y. Okay, so object to test, this is still doing that same logic I did for the snake, so it's just checking the first array segment. So that's the first thing we're going to have to deal with. Sometimes we'll be testing an array here, so we can do an if condition, if object to test. We can use this, so is. There are lots of different comparison operators here. They look a bit weird if you're coming from .NET or something. We're not doing equals or equals or like this. We always provide a hyphen and then we try and complete it with one of these. So there are lots of comparisons and these are kind of similar, some of them, like or, and, less than, or equal to what you'd see in Bash. But for now, we want to know if this thing is something, which is because we're in a typed language, we can check if this is an array. Because if it's an array, we want to loop through each of those objects in the array. So if we hit any of them, let's return true. Otherwise, we'll just let it fall through. And I guess we'll just chuck an else in here. It's a bit messy, but who cares? If it works, it works. It's time to refactor it at a later date. Okay, so if it's an array, we do this. We loop through each object in it. Otherwise, we're just going to check the position of the object, which we don't need these square brackets for anymore. Otherwise, we just return false. It's kind of janky, but should do. Now we just got to update these to take our new function. So if we do test collision, hopefully Copilot susses me out. Object to test is snake, and position is X and Y. Do the same thing with the food. Object to test, food, and we hope that we haven't broken our script. Yep, so we're still drawing what we thought we were doing. This here will just come in useful when we need to do things like check if the snake has hit its own tail, or check if the snake is on top of some food, because then we want to increase the score. Okay, now we're into the movement. So at the moment, we're just leaving the snake as is, and our game runs one frame and then quits. So we're going to need to think about how we can keep updating the state of play and animating as we go. For starters, let's just pick a direction. Arrow up, arrow right. Let's use arrow right. I know that later I'm going to try use the arrow keys, so I'm using the arrow right here instead of just the word right to pick my directions so that I can do less work. Now, while true is going to sort us out with a loop. So we're just going to keep looping until the snake is done. Right now, if we do this, it's just going to keep printing the game board over and over again. So we need to figure out how to move the snake based on the direction we have. So we're going to just deal with the snake as if we're getting a new copy of it each time. Snake. We'll use, I think it's suggested move snake. That sounds reasonable. And we're going to give it the snake, the direction, the width, and the height. Why do we need all of this? So we give it the snake. We're calling move snake, which is going to just give us a new version of the snake, which we're going to overwrite the old one with. The direction is required because we need to know which way to point the snake. And the width and height is required because if we get to the end of this, we need to wrap back around to the start. So we need to know how wide it is before we change the position. So let's jump in here and come up with a logic for moving the snake. Copilot's so good at this type of stuff because everyone's written this type of game over and over again. So we'll just, oh no, that's too much. We'll start with doing it ourselves. So we have our parameters. We have the snake, the direction, the width, and the height. And the first thing we're going to need to do is probably, yep, like it said, grab the head. So why do we want to grab the head? If you look at this, what we're going to do is basically drag this object. So we have the current position. We're going to drag it to the right, and then we're going to leave it like that. So if we were to hit some food at this point, when we hit the right-hand side, that's when the snake would grow longer. If we were not hitting food, we can just get rid of its tail. This way we can just consistently think of the snake as being like, we grab the current position, we position a new head in whichever way it's going. So if it was up, we'd position a head up here, and then we can figure out if we need to remove the tail at a later date. So we're thinking like stretching the snake. And what we're doing here is referencing snake 0, which is our head. And I'm going to call .clone on this because I actually want a copy of the object. I don't want a reference to the object itself. And now we're going to use that direction. So switch direction. That'll do it. This is like a case statement. If it's arrow up, we're going to subtract 1 from the y coordinates. So because we're doing this, the way we're rendering it is from row 0 up here down to row 10 down here. If we subtract 1, we're going to move them up. Okay, so arrow down is y increase, arrow left is x subtract, and arrow right is x add. So in theory, we now have the head being dragged in one direction. And we're going to need to return the new snake, which for us is going to be snake plus the new head. Now this is not going to be happy because I actually want the head at the start and I want to add it to the snake. What is going to be happening though is head is going to be a hash table and snake is going to be an array, and I can't add to a hash table, but I can be cheeky and stick this inside an array. So really now I'm just adding a one item array to an existing array. So we'll see what this does. Intro to scripts, let's run it again. So you can see it started rendering really poorly, but it's just drawing them one after the other. So we took the position, we moved it, we moved it, we moved it, we moved it, and then we carried on. What we haven't catered for here is the wrapping. So if we add that now, we can just say something like wrap around. Oh, I forgot to say please to the AI. I don't want it to get angry. So if the head x is less than 0, we're just going to chuck it at the end again. And if it's greater than or equal to the width, we're going to set it to 0. So that should handle wrapping. It's probably not the greatest way to do it, but it'll work. And it also needs to handle the Y wrapping. So now if we run it again, we should see it come off the end here, then wrap around to the start, and then kiss its own little bottom. Yeah, there we go. So cool, now we have a wrapping snake, but we're not really dealing with any of the direction input. So how do we tell this which direction to go? The basics for getting input from a user in PowerShell is to use something called read host. So previously we were using write host, which is going to write everything to the terminal, and read host does the opposite. So it'll stop the host and ask you to enter something. So if we do something like this and say, yeah, enter a direction, it's just going to ask us. So if I type arrow, oh my gosh, I'm going to have to spell this right, arrow right, it's moving right. And if we want arrow up, it's going up, arrow right, arrow right, arrow right, arrow right. So that's not a very good way to ask for input for a game. But because we're in PowerShell, we have some nice ways of doing this. We're going to drag this out into its own function, which we're going to call read direction. And we're also going to provide the current direction, because read direction is going to read any key, and if we don't have any valid input from the user, we're just going to return the current direction so that we don't overwrite this with something garbage. Now let's try to figure that one out. Read direction. Read host is not ideal. That's what we were previously doing. And this is the direction we wanted. Now, I don't know if I've touched on this, but PowerShell is a whole lot of C#, a whole lot of .NET behind the scenes. So we have access to all of the .NET ecosystem. which we can access through these square brackets. Now, if I come down here into the terminal and do an example, if we do something like, oops, I'm well off my keys, console, system.console, that's actually the .NET console. So it's the same as what would happen when you're writing in a .NET application. You write line, hello. It's actually the same object. Now, system.console, we've got this weird format, which I don't know if you've seen something like PHP. I think this is a very similar format for accessing static methods and properties on an object, or in our case, system console. So this is how you access anything in the .NET namespaces. If you were to do like, what's one of the one? System threading.thread, you could access all of the stuff that's available there. But I don't want to do that. I want to use console. And because we can just shortcut it to console because we're already in the system namespace, we can check for functions with control space. Now we can see what we have available. One of the useful ones, I think, is going to be this read key. So we want to read a key from the keyboard. And if I hit enter now, it's just hung. So what it's doing is waiting for me to press something. If I type something like this R, for starters, it writes the R to the window and then it outputs this information. So if I were to assign this to a variable and then type something, it still writes the R, which is a little bit annoying because I want to actually just kind of swallow the key press and handle it myself. So if I were to come up here and be doing this, console, we get autocomplete up here as well. So what was I looking for? Read key. You can see here there's two options for read key. We've got read key and read key with a boolean as the first parameter, which is called intercept. And if I were to go online and look at the docs for this, it's going to tell me that intercept is going to just kind of swallow the key output. So that's what we want. We want read key true. I'll try it down here just to prove it out. True. And now if I press character, it didn't get output to the terminal and I get the info about it. Before I used arrow right because I knew when I do this, that's what this key looks like. I totally got it backwards. It's right arrow. Gosh dang it. So now I have to go back and refactor it. Anyway, I thought I was saving myself some time. But what we want is to go flip those around. What do we after that? Oh, whoops, I entered text mode. Yeah, we want those. All right. That's all good. So now we're back to where we started. Right. So console read key is going to give us the key. And this is new direction. And then we need to handle it. So I guess new direction, we only really want to assign it if it's a valid direction. And I'm going to be lazy and just put valid directions here and hope that Copilot doesn't see this because it's going to think that that's those direction names. There we go, up arrow, down arrow, left arrow, right arrow. So that's all we're going to do. We're going to check that if valid directions contains new direction key. If it does, we're going to return that. Otherwise, we'll just return the original direction. So now with read direction, we should be taking, we're giving it the direction that we currently are facing. We have a list of valid directions. We're pulling in the current key press that the user's pressed, and if it's one of the valid directions, we're going to return it. Otherwise, we're going to return the existing one. So this will just silently swallow all the other garbage keys that I type. So if we do this now, oh yeah, it's paused because we're waiting for a key press. This is not an ideal scenario, but now if I press up, then press up again, then press up again, the thing's getting slightly longer, right, down, we're seeing that it's outputting the keys. And if I press something like the W key here, it'll keep moving down. So it's returning the key that we want. All right. So we've handled a little bit of the direction, but that is not a smooth way to play. So what we would prefer is to only actually pause it here if there's a key to be consumed. So we can check for other options on console. And I might have crashed the language server. Console. Yeah, it looks like I have. Let's try that. Sometimes, just like with TypeScript, it just needs a quick kick in the pants. No, we've lost it. Oh, we'll do it down here. Console. We have something for checking if there's a key available. So there we go, key available. Is that a function? No, it's just a property. Yep. So we can check that here. Yeah, weird. We'll do it that way. Thanks, VS Code. If the console has a key available, we'll handle it, and then we'll carry on our merry way. So you can see it's just plowing through and flickering all over the place, but it's only handling my key presses when there's one to be handled. So it's starting to look pretty messy. We probably want to just start rendering it properly at this point because it's getting pretty hard to debug it when it's doing that type of thing. So if we now come up to the right game board, we can use one of those weird escape characters. So we know the escape character, and we know that after drawing this, we want to move the character thingy across here and back up to this corner so that we can draw over it again. Luckily, there's a command for this. So right host. Now this is where we're going to use one of those weird ones. Backtick E. It's kind of come up with something that looks right, but I think it's wrong. What I want is 2A. Let's go back to our escape code thing and check what I had there. Move cursor 1 up, so that was 2A. So we want to go back to the start of the line, Control R, or backtick R, and then also we want to go up the height A. Weirdly for us, because this looks like a variable, PowerShell's trying to think the variable name is actually height A, so we can use these curly brackets to tell it that height is actually the name of the variable, not that extra piece. And then we probably also want to do no new line here, because otherwise right host is going to chuck a new line on the end and ruin our output. So let's see what this looks like. Yes. Now we're cooking with gas. All right, so it's still not working very well because our snake is constantly stretching and getting longer and longer and longer, but that can be the next thing we address. So we've got a stretchy snake. We've set the direction and we're moving it. We've figured out some ways to collect input with PowerShell using the built-in read host and also with the system console. And now we need to start figuring out how to deal with this snake getting stretched all over the place. So the first thing we're going to do is work out if it's eating food, because that's when we know that the snake, if it's eating a piece of food, the snake's going to get longer, which it currently is just doing on every iteration of the game. So what would we do? We use that test collision function that we already had. So we've just moved the snake here. Now we want to check with a test collision. Object to test is, what is it? It's the snake. And then we want to check if it's hitting the food X and Y. And if it is, we don't need to do that. That's just Copilot being bad. We want to get a new piece of food. We want to increase your score, which we currently don't have here. Let's start at 0. And for good measure, let's tell you what your score was when we finish. There we go, that was a nice little, your score was score. and that is the score increase. So, well, now that we've just added that small piece, we'll just make sure when we hit the food, it actually does cause it to generate a new food. Oh my gosh, this is so hard to deal with. Oh, there we go. So you can see it generated a new food down in the corner. But now we need to handle that snake getting longer every time. Else snake, whatever this is. Let's write it as a function just because we've written functions throughout here. Remove snake tail. Now we give it the snake. Sometimes it's handy just to write functions just so that when you look at them you can tell what it was doing, because this looks pretty obscure. We give it an array and it's come down here and suggested an option for us. So what it's doing is it's taking the current snake and it's filling its array index operator thingy with this chunk of spaghetti. What it's doing there is a range operator. So if we do something like 0 -- 123 here, it's going to write out the numbers between 0 and 123, which is what it's doing in this array accessor. So if we do something like Sean, that's a variable now, .to character array, that's now an array. And if we want to grab array index 1, we've got the H because we're 0 based, I forgot about that, or 0 is S. If we want 0 to 3, we should get 0, 1, 2, and 3. So we've got SHAU. So that's what's happening here. It's taking the snake length and subtracting 2. Subtracting 1 would give us the entire snake because that's the array index of the last piece. So subtracting 2 gives us the snake minus the tip of its tail. And because we're stretching it every time that the snake was being drawn, we know that there's always a piece of tail to remove. So we're always going to be dealing with at least a snake of length 2. So this works. So let's give that a crack and see what it looks like. And now it looks a little bit more like the game that I had previously on the Nokia. Now we can also hit this and hopefully the snake gets longer. And at this point we've basically written the entire game. So that's pretty cool. It does have a little bit of an issue with that flickering white block that's just happening all over the screen. It's kind of showing you as well where the cursor is. So you can see that it's constantly flickering across the screen, then back up to the top left. I have to press Control-C to exit that because there's no other way to exit the script. Control-C, by the way, exits any currently running thing in the terminal. It's a very handy command to know. So just keep hitting Control-C if in doubt. If you accidentally start a script you're not supposed to be running. Okay, so our remove snake tail is working. That flickering is a little bit annoying and makes it look garbage, so we'll deal with that right now. If we're looking at the write game board function, we can do something to turn the flickering off. There is an escape code for it, but I can't remember it off the top of my head. So I'm going to use the console. Oh, this thing's totally broken now, so we'll just do it the hard way. Console cursor visible and set that to false. Everything you write in the script up here, you can run in the terminal line by line as well, which is very convenient when you're writing these things. You know, if there's no build steps for this, you just write some code and it JIT executes it. All right, so now we shouldn't have the flicker. That worked. Yo, look at that. Isn't it a thing of beauty? I don't know how long it's taken me to get here, but I've reached peak developer. All right, so I still have to press Control-C to exit because I haven't handled the next piece, which is, oh, we've already done that, rework moving snake. Game over, so how to deal with the game over scenario. Now, this is what I screwed up when I did the live demo because I accidentally put the detection for if I'd hit my own snake in the wrong place. So it was just spitting out errors. And now it makes sense that I was checking it after removing its tail, which was the wrong thing to do. So if I want to check if the snake is colliding with itself, we can do it up here and it would work perfectly fine. So what we want to do is test, the object to test is the snake itself, because if you can remember, we put in object to test and here is an object, and we check if it's an array, so we can do that. And then position X and position Y is going to be the snake's head. So snake 0 is our head, just because that's the way around the array is. And it's also thought that we've got the skip head parameter, but we don't care about that. Let's just see what happens. Because we're in a while true loop as well, we can just break at this point and say, yep, game over, done. And then down here, it's going to write the game score. Let's give that a try. Let's see if we can crash into ourselves. We did it again. All right, see if I can figure this out this time. We move snake, test collision, the snake with its snake head. So what we want to test is actually not the snake itself with its own head, because yes, it's going to collide with its own head. What we want here is a very similar array index expansion thing than we had before, which is going to be 1 to the snake length. What did we put in there? Snake length minus 1. And because we have a snake here and we're always stretching it, after this first move, it's going to be a length of 2. So snake 1 to 1 is going to give us just the second piece of the snake, just the tail. So I'm confident this time it'll work. Yeah, I totally screwed that up and fumbled pretty hard during the preso. But this time around, we're good. Now, I haven't done some stuff in move directions. So right now, if I press backwards in the opposite direction to which I'm currently going, so if I press left now, it should drive into itself and crash and tell me my game over, my score is 2. That went so much freaking better. All right, cool. So we have a game over scenario. This is actually somehow looking pretty clean. I feel like there should be one more problem here. Come on, crash. Huh. Oh, my terminal is currently cleaning it up for me. So at the moment, I'm writing game over, your score was 3. And it writes it over the line that was rendered. And then the terminal goes and spits out this, which clears out the rest of my terminal. So we are good. You could also do something to clear out the bottom of the terminal here. So game over, your score was score. Oh no, that works pretty well. We're writing the game rule, we put our position right back up to the top left-hand corner of it, then we write game over, and then we are back into our shell. Cool. So yeah, it's working. All right, there was one other thing I also wanted to touch on, which is why I love writing PowerShell scripts. And that's because, as well as what we've shown here, which is a lot of the magic you get, like types, you get the ease of modules, you get the nice function stuff, and you also get a lot of very familiar control flow. So ifs and for eaches look just like they would in a lot of languages. You also get a very easy way to deal with web APIs. Because we're dealing with .NET, it has everything you need, like JSON serializers, deserializers, all built in. So when we want to do something like access a URL, like one I've prepared earlier, I have a scoring server here, which is just running. Hopefully this is still running, which is going to give us a list of scores. Now to get that, normally on other languages, you have to install a tool like curl or wget to get that. But we can go and tell it that we just want to do invoke REST method. Now there is another way to do this, which is invoke web request. That one there is a little bit, it's just going to give you the text of the output, but REST method does a little bit of smarts around how it's going to actually parse the output of your API. So if we put in here this one that we got, it should deserialize that JSON text into an object that we can deal with. And we're just going to output the scores. Out host is like write host, but instead of text, I'm outputting an object. And this pipe here is a way of passing it, an object being piped into something. These are very common on terminals because is things still set? No, we'll set one again, things equals Sean. When you're writing stuff on the terminal, you don't really want to keep hitting enter because every time you hit enter, it executes. So you have the option of piping to the next command. So for this, we can do like write host. You can see there, it's the same as doing it the other way around. Write host message $things, but we can chain them together. So it becomes very convenient. And it's just the way that I'm familiar with writing these scripts. So for outhost here, we're going to see hopefully that it outputs some text from that API. And we will just die immediately. And this is where my corrupt output is actually happening. So cool, we got game over your scores too. We've also got leftovers from our rendering. And then we have this table here, which is actually this, which is being turned into an object for us. So scores here is the people that are currently on the scoreboard. And I want to fix this poor rendering. This is what I got hung up on before because I thought this was going to happen. There's a way to clear out everything below your current cursor. So what happens is you get to here and you send a control signal which says, I want you to wipe out everything below here so that I can start rendering cleanly, which I think is J0 or 0J. We'll see if that one works. Cool. 0J must have been it. So what it's done is it's wiped out all that blue stuff and written cleanly on top of it. Okay. We have that now, and accessing data via REST API is just as easy as posting it. So if we do something now, we can do invoke REST method. And then we want to post it to the scores, which it's actually suggesting for us. So we've got the URI that we want to post to, which is this one here. We've got the method of post, and we've now got the body, which out of the box, I think this isn't going to work. It's probably going to try and send this as XML, so not as XML, as a HTTP post as a form, which is not what we want. We want to post it as JSON. So we'll try it and see how it goes. And we'll use my username. I can probably just copy this and run it on the command line to see what happens. Yep. Unsupported media type. Yep, because we are doing a JSON API. So what we want is to provide content body, content type, sorry, whatever, application JSON, application / JSON, and then the body is going to be this, but I need to convert it into a JSON object. Let's just do it separately. Body JSON. So that's what we want to do. We could have done that all on one line, but sometimes it's not worth it. And then we want to, oops, I lost it. Let's just do that again. So we got name. Again, I was using my environment variable, which is what I've got here, $env:. You can see I can access any environment variables. Username. And then my score is going to be score. The API, I think, actually takes value as to what the score parameter is called, so we'll do that. And then body JSON. Body JSON is just going to, we'll call this one body. And I'll do it on the terminal just to show kind of what's happening. So if we have our body, which is a hash table, it looks kind of like that. We haven't set the value because down here in the terminal, score isn't set to anything, but up here it will be. So we want to convert that to JSON, and we can pipe this into a function called convert to, and there are different formats, but for us, we're going to want JSON. There's a lot of them. Let's just do JSON. So you can see we've converted to JSON. We can also just help to compress it to make it a shorter form, but for us, that's going to work. Let's call it body JSON. JSON. All right. Now, in theory, this should post your new score, but we want to do that before we output the current scoring. So let's see how this works. So what we're doing is we're going game over. We're taking your current username and your score. We're converting it to a JSON object. So I just don't like the way this looks. I'm just going to chuck it up there. And this is called body JSON. and then we are posting it to the scoring point and then getting the new scores. So let's see how that looks. All right. Let's try to get a high score. I don't want to get beaten by those 3 characters in there. All right, that's good enough. Cool, so I got 5. And so this post here has posted to the endpoint, added my new score, and then when I got them, it's come back. So it's as simple as that for dealing with APIs, which if you're doing a lot of PowerShell stuff, you're often in the middle of like doing scripting automation, and all sorts of APIs are using JSON, so this is super, super convenient for being able to access and work with them. That is a little bit about the cool stuff I like. And the last one here was something to do with testing, so I'm going to just wing it and hope that I don't have to write my own tests. Usually I wouldn't write tests for a script, write tests for the module, so I'd write tests for these module functions, and we're going to see if we can just take the lazy route and ask Copilot. So, hey Copilot, test, please, for the snake module. You got to say please in case they get angry. So what it's trying to build are some PowerShell tests using Pester, a popular testing framework for PowerShell apparently, which is basically the only real option you've got for writing unit tests. And we should be able to see if this works. Oh, I hope I have the right version of Pester on here. Probably will. So let's try this out. Set into new file. Let's do it. Import module, so that's importing the file to be tested. Again, I'll use force just so I always pull the latest. And it's suggested a name for me, which is snake module test, which I'm going to use. Snake module test.ps1. So we've got the rough outline of a test framework here. We've got a describe block, which is describing the outermost thing that we're testing. And then we've got here context. So it's saying that it's writing the test for get random food. Those don't have to be your function names, but it appears it's done that. And it's gone with the format of get random food, and then it's checking that it has the X and Y parameters. They're very simple tests. But it looks like here it's also testing that if given a width and a height, when you get a random food, it should be less than those. So that's quite cool. And write game board, that's a very simple test too. It just doesn't throw an error if you provide the right parameters. So let's see how the tests run. What you'd normally do to run tests in here is to write invoke, which is another function, and Pester. So Pester, when you install it, you would do install module Pester. Let's just try do it anyway. That's how you install PowerShell modules. And I think it looks like I've got an old version of Pester here. We'll just try and I'm not going to try and mess with it. Let's just try and invoke Pester. So if I do get module Pester list available, it's going to tell me what I've got. I've got a really old version down here in the PowerShell modules, and I've got a newer version up here, and it has a bunch of commands that it exports. So invoke Pester is the one I want. If I read the docs, it would tell me to run that. And invoke Pester is going to search through this current directory and find any .tests.ps1 files to run tests for. So it looks like it actually passed. Those are better than most of the tests I'd write. So it's gone and run those 3 things. It's pretty basic. You can see it also actually printed out the stuff on the screen while it was running the tests, because these are pretty garbage tests. But you can see writing tests for PowerShell is not super difficult when you start. You don't have to do a lot of wiring. You just throw one of these files and then start writing invoke Pester. So where are we at the moment? We've covered a lot of ground. I actually don't know how long I've been talking here for, and I have no idea how I was supposed to fit this in 45 minutes at that presentation. If you're familiar with Bash, I hope you've seen some of the similarities between these tools. Like, they are very similar in some ways, very different in others. And if you've seen a lot of stuff with C# before, hopefully a lot of this looks familiar with you. And that's really one of the things that is like got me right into PowerShell is this is now available everywhere. So it's available on Linux, Mac OS, and Windows. It's not just a Windows thing anymore, and it is very functional on the other platforms. There are some things that don't work, but more often than not, I can make things happen. And it's also available in all those things like your GitHub pipelines, GitLab pipelines, uh, Jenkins, all of that stuff. I do a lot of platform engineering stuff, so development tools and development tooling, and this is usually the tool I lean on to do an MVP before I start writing something in other languages. So it's a really cool thing to have under your tool belt. And if you've got any questions about this, hit me up on my LinkedIn, Twitter, or whatnot. And I've got here, check out your CodeCamp bio. If you got this far, that's pretty awesome. Smash that like button, and I might make one more video in like a year's time.